All right, so the first section is 2.1. So I remember when I first taught this, a lot of people say I'm just saying set and notation, all that kind of stuff. It does seem like the same word over and over, but they are different. They are different. So now we're doing set notation. You probably do not remember it from a long time ago. It's a little different. It's more going into the calculus, trigonometry, calculus side of math, but in the upper level, it's a little more than algebra. But it's not. We're not doing all the difficult stuff. So first, I want to talk about a set. A set is a collection of objects made up of specified elements or members. It can be numbers, words, or anything of that nature. Now, there are roster notation. What helps me memorize roster? When you think about a class roster, it's like a list of people. So when it's going to ask you roster notation, you're going to list out all the elements in that set, and it's going to be surrounded by commas and curly braces. So here's one problem that was omitted. So I can show you what roster notation means. So I'm going to add in this question. So the first one is S is the set of states in the US that begin with the letter M. So now if I want you to write that in roster notation. So again, we're not doing math problems where we have to say 1 plus 2 and all that kind of stuff. So we're trying to figure out how do you list the elements. The elements are things inside of a set and it can be separated with commas. You want to think about the states in the United States that begin with the letter M. Now it says S is the state, so you're right, S right here. So you think about it. What states begin with the letter M in the United States? You will start with the long one first. All right, yes, you're right. Mississippi is one. And I was like, oh, God, and I was really thinking Maine. Okay. Yes, but that's right. Okay. Isn't there a song with how you spell Mississippi something? Miss two cents. Yeah. Okay. All right. But that's close. We know Mississippi. I'm gonna put MS. Do what? Oh, yes, yes, that's right. That's right. That's right. I do remember that. All right, Maine. We'll just say Michigan. Now you see what we're doing. We're listing out. So when it says roster notation, you list everything that starts with M. So we have. Oh, what do you said Maryland too? What else can you all think of? Yes, yes, yes. And some days the spelling just goes out the window. What about Montana and Missouri? These are good places to visit, huh? Monday, Missouri. All right, so how many do we have now? I think that's it. Can you all think of any more? I'm gonna make up some states. All right, so it is 8 of them. Yes, 8. So when they say the roster notation, and that's the hardest thing on a test, it'll say list and roster notation. So your mind has to go through what is roster notation. So you have to say, okay, I have to list all of these things out that start with the letter M. All right, so I'm just going to write, I'm going to say this next question. All right, give the sets. I have to write this. And well, this is one situation. Let's see if I can add a slide in. I don't know if I can on this one. All right, so here are the sets that you'll have. No, it may not be in a recording, but if I just list the sets, and they'll do things like this to make you think. Blue, comma, red, comma, green. This is a set. And then the next one is red, white, blue. And then we have blue, green, and aqua. Then we have the last set, which will be red, comma, white. And it says, let T be the set of sets that contain the element red. So you will have T, and we're going to put our brackets. So which sets will contain the red? Correct. So your answer would be, I'm going to put a star. You would rewrite the blue, red, green, and you would rewrite the red, white, and blue, and then you would rewrite the red, comma, white. And for the sake of space, you would do it just like this. You would say, hey, this is one set, red, comma, white, comma. Then you do the next set, which is red, white, blue. And then you would do comma the next set, which would be blue, green, red. So they basically, it's just really reading, and it's kind of hard to teach you some of this stuff, and it is a lot of reading comprehension, putting this stuff together. All right, so you just put all this inside of brackets. This is the set. So the curly braces mean you're in a set. So you just kind of have to read the problem, and that's what some people think is kind of hard because we're not actually doing a computation. It's just reading and make sure you know. So it's everything except the blue, green, and aqua. And you just list these sets. These braces are the elements within the sets. And this is set notation because you have the curly brackets on the side. And then they'll say let T equals. So this is where this comes from because the problem says let T be the set. And like I have here, let S be the set. So that's why you were leading with S equals. So just getting you on that mathematic style of thinking. Oh, you all actually kind of have the answer right there. You just don't have the question, right? Yes, okay. So you need the question to go to it. All right, that is it. Okay, very good. All right, so now the next part. I left that part out, so I'll make sure to do that again. Oh, and I did all of that beautiful writing. It's right here. Okay, well, there we go. We have it all together. Yeah, and that explains all that. All right, so now we go to definition. Two sets, this is the fun part. Two sets are said to be equal if they contain exactly the same number of elements. So if A and B are equal, we write A equals B. And that's like that. It's not really hard. They're equal, just going to be equal, right? They're going to throw some kinks in there in just a second. So the notation absolute value of A can mean either the cardinality of the set and the absolute value of some number A. The meaning of the notation depends on the context. And so here we're going to talk about cardinality. So I will start some words that you have to remember. So make a little note or highlight. You have to know what roster means because this is something that you don't do every day. And then now we're going to add equal to it, kind of like a little mini study guide. And then we're going to add cardinal. All right, so just kind of putting it together because we're going to go through different words. So cardinal number, the number of elements contained in a finite set is called the cardinal number. That means, and just a set number of numbers. The cardinality or the cardinality. The cardinal number of set A is denoted by just absolute value of A. And you think something, we're going to ask you, what is the cardinality of a set? And you think like, oh, that's something hard. But I'm just going to fast forward. The cardinality of this right here is 2. Because how many elements do you have in here? 2. So you just want to mess with your mind. But that's what people will miss on the test. What is cardinality? What is the cardinality of this set? 3, because you have 1, 2, 3 notes. So that's just a definition. Make sure you remember cardinality. That is just how many is actually in that set. And then the next definition is equivalent. Let's do that. So we have equal and we have equivalent. And I used to get kind of upset, like, why are they giving us equal and equivalent? It means the same thing to me, really. But nope, they're going to do it a little bit different. So this, you have the definition. Two sets are said to be equivalent if they have the same cardinal number. If set A is equivalent to set B, we can write just a squiggly line. A is equivalent to B. So guess what? Sometimes you're going to have sets that are equal, and sometimes you're going to have sets that are equivalent. So I want to see it. Here it goes. That should be next. Oh, this is just how you notate the cardinality. Yeah, you can do N of A or the A with the bars or just the number A. And then that's the same thing. Equality means that they're equal. That's just how we write it. So let's look at the first question, the public health. So determine if the given pairs of sets are equal, equivalent, or neither. Here's that word, neither and neither. Okay, so A, you have public health, international studies, mechanical engineering, music education, political science. Then we're going to look at B, Tim, Gloria, Alan, Warren, and Khalif. So let's count. 1, 2, 3, 4, 5. So the cardinality of this would be 5, right? So look at B. 1, 2, 3, 4, 5. So the cardinality here is also 5. So would you say that A and B are equal or equivalent? They would be equivalent, but they're not equal because does public health equal Tim? Does international studies equal Gloria? No. But they have the same number of elements, so therefore they will be equivalent but not equal. So you would have to write A equivalent to B. So you have to think about it like that. Are they equal, equal, equal? Like, do we have the same thing? That's what you want to know. Now they can be in different orders. Well, we're gonna kind of do that next. They could be rearranged, but they need to be the same thing. So now let's look at B, X and Y. So we count all the elements here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they have the same number of elements. Now, are these numbers the same? Yeah, I think they are. Like this is a 2, but they all mixed around, right? So this would be equal and what? Equivalent. Yes. So we can say A is equal to B and A is equivalent to B. Because they contain the same number, the same elements, and the quantities are the same. The cardinality is the same. Any questions on that? So it's kind of the different words, play on words a little bit. And here's the same explanation we just did. All right, so this next one. Find the cardinality of W and Y. Determine if the sets are equal, equivalent, or neither. So how many elements do we have here? 1, 2, 3, 4. And we have 1, 2, 3, 4, 5. So what do you think? Neither. Because they're not equal, they're not equivalent. There's just X and Y. And I believe I downloaded now I'm thinking about the wrong. So I'm gonna have to skip through some. I downloaded the wrong PowerPoint that doesn't match yours. But it's okay. This just has extra. All right, so now let's go to the empty sets. Because remember I told you some things that we skipped through. So that's right there. All right, so the empty set is the set that contains no elements. If set A is empty, then you're going to write it with the 0 with the slash or just braces. So it's a little weird there, just nothing there. That means it's empty. Okay. So the cardinality of the empty set is 0. That means, you can't count anything there. There's nothing in there. It's just nothing. So now let's look at these. Determine if the following sets are the empty sets. So you look at the first one, A. A is such that X is a negative number less than 100. So think about that. Can you do something do you have numbers that are less than 100? Does that exist? Yes, we have 1, 2, 3, 4, 5, right? So would that be an empty set? No. This is not an empty set because we have all that. All right, so that's not an empty set. So B, the set B of any state that contains the letter Q in its name. So can you think about any state? They will give us 50 states to go through that contains the letter Q in its name. That's kind of unique to think about. I'm thinking about them. Can you think of anything? Hawaii, California, Georgia, Texas, Tennessee. So that would be an empty set. So these people really think about some things, right? So this is empty too. So you can write it's empty. We can do this or it is an empty set. Yeah. But this is not an empty set because you can put numbers in that set. All right, and so this is kind of hard to see. So C equals, see the brace. Remember I told you there's nothing on the inside, but there is something on the inside of this, and it's the underscore. So is that technically empty? No, it's not. Because of this underscore character. They just want to mess with your mind. If it was something, if it was just like this, then yes, it would be empty. But no, this is not empty because, I'm just abbreviating, because of the underscore character. So just something to make you don't see it as being a whole number, but they just put something there. So something is there, so therefore it's not empty. All right, so empty set just means it's empty. Nothing is there. Nothing is there. And this is the no solution, so that's the same thing as empty. And I have to go past these to get to it. All right, so your next question states, determine if set Y is the empty set. So Y is X such that X is a U.S. citizen who held the office of president before Barack Obama, and X is a woman. That's empty. Have you all know anybody, a president that we had that's a lady? Nope. So you say Y here, empty. Doesn't exist. That's empty. So yes, that is empty. All right, so universal set. The set of all elements being considered for any particular situation is called the universal set and is denoted by U. All right, so now we're going to compare everything to the universe, but we're going to get to the problem in a second. So the complement. So that's another word that you're going to have to write down. The complement is another good, and empty. Be empty. So the complement of set A consists of all the elements in a given universal set that are not contained by A. So actually, when you're doing the complement, the notation for complement is going to be like A with an apostrophe or whatever. You can have T with an apostrophe, whatever you're dealing with, and it has an apostrophe, that means the complement. And one thing you can highlight on your notes, but you need to know it's not. What is not contained in A. So the complement means the same as not. And they have different ways they're going to notate the complement, but the most popular way that I will do it is just the A with the apostrophe. That's just what I'm doing. Just that one, A with the apostrophe. That's a complement. So now let's see, what is a complement? They give you situations again about what the complement is and all that good stuff. So let's think about it. According to a recent poll, approximately 30% of American adults have at least one tattoo. All right, so we get that. Now, the universe, this is all the American adults. So, the universe, everything is going to be compared to the U. The U is the whole situation. So, that's that. So, now A. X is such that an American adult who has at least one tattoo. So, if you're going to do the complement, you're going to do what's not here. All right. So you're basically going to say what's in the universe, but it's not a part of A. So you have to think about it in context. If you're going to see what person, how would you write it in set bit of notation if you're talking about an American who does not have at least one tattoo? Now, this is the answer over here, so I'm going to let the answer for us writing, okay? All right, so you got that in your head because it says what it's not. All right, so it says since A consists of American adults who have at least one tattoo, And the complement of A consists of American adults who do not have at least one tattoo. We know at least one means greater than or equal to one, correct? Great. So does not have at least one implies has less than one or simply no tattoos. So this is what you would write. This would be the answer. I read all of that to explain. The complement would be if the person has at least one tattoo, then what would be kind of like the opposite of that? They have no tattoos or they could have more. So if you would write that one, and you have to say X is the element of the universe and has no tattoos. And because if they have at least, then the opposite of that would mean you would have no tattoos. I like the numbers to do instead of the situations. So we're gonna have the Venn diagram, we're gonna have numbers. So you have to just kind of think about these. But personally, I do give you more numbers you're gonna have on your test, like what's the complement. And let me kind of tell you, I'll just give you an example. Like if I say U equals 1, 2, and 3, and then I tell you that A is equal to, let's say, 5, 1, 5, and say 3. And the complement would be what's in the universe that's not in A. Yeah, it would be 2. That's what you meant. The complement of A. That means what's not in it. So because it has the 1 and 3, but it doesn't have, it's missing the 2. So I would give you more of the numbers, like what's not in A that is in U. And so that would be the 2. But I would give you a whole set of numbers, just pick out what's not in there instead of asking you to reverse these situations. And so they were saying really too, I can't count it wrong if they said 70%. So if you say this could also be written as has no tattoos, blah, 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 about 70% of adults. And actually that makes sense to me because they say if 30% have at least one tattoo, I would say what's the opposite of that? The 70%. So actually I really like this one better. So that's the good thing about the quantitative reasoning skills. If you can explain your point, it makes sense, that works. So either of these would be the same situation, either no tattoos or 70%. All right, so for B, the situation for B says if an American adult who has exactly 2 tattoos. So they're saying if they have 2 tattoos, what's the opposite? If you don't have 2 tattoos, then this sounds better. Who does not have exactly 2 tattoos? Can you just do that? Just put not in front of it. That's the same situation, just not. So if you have the 2 tattoos, then what's the complement? You do not have it. And then they even got even more technical. You could say, well, if you don't have 2, then you can have either 0, 1, or 3 tattoos. And that would work too because it's just anything except 2 tattoos. So just anything except that. That's what and I guess that's what they're really trying to show you. But sometimes a lot of words can be a bit much, just if you can keep it short and simple. So again, I want to emphasize they want to know what's not in that set. That's all they want to know. What's not. All right. And then we do have another one for the skill check. It's more words, but let's see if you can think about it. It's not the best, but let's see if you can come up with. Do you have the answer on here? Yeah, you do, but you don't try not to look at the answer. You do have it. So we have the universe. X is a book published in the U.S. in 2021. We're talking about all the books published in the United States for 2021. And so A, X is all the books in the universe, and you read X as an ebook. So the situation in A, you read X as an ebook. So how would you do the complement of A? What do you think? They're saying you read an ebook. So what would be the not? If you didn't read an ebook, then what could you have done? Well, do you all read ebooks? Okay. Well, if you don't read an ebook, then what kind of book could you read? Yeah. You could say that. You could read a hardcover book, a hard copy book. Um, and that would be it. Yeah, I want to see if you're right. Let's see. So it says, and you did not read. Well, look, they just made it simple for you. You did not read X as an ebook. So if you didn't read that, if you didn't read the ebook, then that means you just did not read the ebook. But then if you say, well, now here you go with two. Is it possible for you to have read a book in A? Yes, because if you didn't read an ebook, then you read the hard copy book or you read the audio book. So that's what it just kind of makes you think, get on your head, yeah. So again, let's try to reiterate. So what's the opposite of A? Just not reading an ebook. And I'm okay with that. Just didn't read the ebook. So is it possible to have read a book in that? Yeah, because you could have read different types of books. You could have read the printed or the audio. So that's what we want you to know. So if you see the A with this, your key thing is not. What is not in that situation? That's what you want to know. So, but they just give you situations to make you read and get all into it. So maybe they're a little better with the Venn diagrams. Maybe we have some. We have some, I think. All right, questions, comments, conjectures. So now we're going to pick up with 2.2. And let's see if I can get the right over